Hi, good evening, everybody, and welcome to today's Theoretically Speaking event, a panel discussion on communicating algorithmic science to the public. Before I begin, just a few words of introduction about the venue and the event. The Simons Institute, where you are, is an internationally acclaimed, unique of its kind venue for research in theoretical computer science, not just looking at the laws of computation themselves, but also taking an interdisciplinary perspective and seeing what the computational view can tell us about other fields of endeavor. So that's the Simons Institute. The Theoretically Speaking event is an event we've been holding for many years now, since 2015 at the Institute, to communicate science, algorithmic science, to the public. And this event, we are lucky to have 3 science communicators in residence at the Simons Institute at the same time. So what better way to take advantage of their presence than to have a panel with all of them? So we're going to have this Theoretically Speaking event be not a lecture, but a panel. Oh, and I forgot to introduce myself first. My name is Sampath, Kannan, and I am the incoming Associate Director at the Simons Institute. And let me say a few words of introduction about each of the panelists, and then they will speak for about a few minutes, trying to tell us what they do and why they're here. And then I have a few questions, and then we'll have the audience ask questions as well to them. It's going to be a packed program, I can see. Alex Bellos there is the author of over 20 books, ranging from math through the various cultures and through history, to various sorts of puzzles and books on football and Pele and Brazil and all kinds of things. His books have been translated into 20 languages. He's a correspondent for The Guardian, and he writes their puzzle column. Ananyo Bhattacharya is the chief science writer at the London Institute of Mathematical Sciences. He has also written a very well-received book very recently on a sort of a scientific biography of John von Neumann. It's called The Man from the Future, and he's going to give a talk on it in about 6 days right here. So please come to it. Upstairs. I'm sorry, not right here, but upstairs. Okay, great. And then Ben Brubaker has a PhD in physics from Yale, but over time, after he finished his PhD and became a journalist, his interests have shifted to computer science and complexity theory. So he's perfectly positioned here when we are holding the quantum complexity program at the Science Institute. That's a brief introduction, and I'll turn it over to Alex to tell us all about himself.
Okay, yeah, so I'm Alex, and my background is maths, really, rather than computer science. So I got a degree in maths and philosophy 30-odd years ago from Oxford. But after that, I did not become an academic. I became a journalist, and I was a reporter and a kind of news desk reporter in London for The Guardian. And then I ended up in South America, where I was a foreign correspondent for 5 years in Brazil, covering all of South America. And then I decided to come home to London and to use the skills that I had learned as a journalist, a kind of foreign correspondent, to write about maths, which is really kind of my first love. So I saw myself in my first book, which Alex's Adventures in Numberland in the US was called. He's looking at Euclid very much as the foreign correspondent in the world of maths. I was the person going out, meeting people, interviewing people, and kind of sending the news back to the people who didn't know anything about maths. And one thing led to another. I've written books on puzzles, etc. And then I kind of alighted on this area of theoretical computer science about 3 years ago. And my first, I had a few sort of instant thoughts. First was, here's an area that I didn't know about. Here's something that's super interesting. And here's something that there is almost no popular science. There are almost no books writing about this area. So I almost felt like I was the first man on the moon. I've got to, it's terra incognita, to mix my metaphors. I've got to be someone, as a journalist, I'm thinking, where's the story? What's the story that no one else has done yet? And I thought this is a great opportunity for me to discover an area and to try and communicate it, because for reasons we're probably going to talk about, theoretical computer science is not very well covered in the media, which is curious to me and was curious to me. and I'm trying to find a way to popularize it. And the way that I'm trying to do that right now is by writing a book on the subject of randomness, and how, in a sense, the last 50 years has been the story of how computer scientists have embraced this idea, which is obviously they didn't invent randomness, but they embraced it in a new way, learned to control it, and have then used to deploy it in many interesting theoretical ways, but also that have had knock-on applications that everyone can sort of understand. So that was the basis for this book idea. And, you know, when you have a book idea, you have the idea, you write a proposal. I wrote a proposal, was accepted. I got a commission for Knopf, I don't know how to pronounce it. And my deadline is the end of the year. And so I am here, in a sense, researching and writing this book on randomness, sort of the computational lens, and how it's changed views of randomness. And that's why I'm here, and that's what I'm doing.
Thank you very much. Alex, do you take publishers' deadlines very seriously?
I do take them seriously.
Okay. I won't mention how many years I overshot on The Man from the Future then. So I'm on a no. I think randomness is a very good description of what I'm doing here. My undergraduate degree was actually physics, and I failed my first year maths exam. And there was two. I failed one of them, and I had to retake. And if I'd have failed it again, they would have thrown me out. But I survived. I switched because I thought my maths wasn't up to doing something really interesting like theoretical physics or astro, I think I was considering, or cosmology or something. So I switched to biophysics, protein crystallography, did a postdoc in protein crystallography, and I realized I was finding science interesting mostly because I kept changing subjects. And I thought, I can't do that forever, so I better go and find something else to do. I'd always wanted to write. And so I came back to London. That was in San Diego, actually, my postdoc. Came back to London, did a master's in science communication, and was lucky enough to get a journalism job, a science journalism job, straight out of that master's. And it was for a pretty obscure publication called Research Fortnight. And it used to annoy everybody at that publication that we always got called Research Fortnightly, even though it was Research Fortnight. But that was about science policy and funding and all those things that researchers are extremely interested in, but nobody else is. So I did that. I think I was there for 3 years. And then I moved to Chemistry World, even though I had stopped chemistry at the age of 15. I ended up becoming acting editor for Chemistry World. That was Royal Society of Chemistry. I was there for a very short period of time. And then went to Nature as a deputy news editor, and then ended up as chief online editor there. And then my final move was to The Economist, where I spent 5 years. Whilst I was there, this name just kept coming up again and again in all sorts of different contexts. So you're surrounded by business journalists and economists, and I was on the science and technology team, so there were people covering AI, and John von Neumann's name just kept appearing in all of these different contexts, ranging from sort of game theory to AI through to quantum mechanics and so on. I thought, this guy's been dead for 50 years. Why are we hearing more about him now than, I think ever before, or at least for the last 30 years? So I went home, and I remember pulling at random all these popular science books off my shelf, and his name was in about half of them. He was always in the index of about half of them, ranging from economics through to, in Consciousness Explained, He appeared in Bronowski's Ascent of Man. There's a very famous anecdote about von Neumann in there, which I'll let you discover if you haven't already. So I thought there's got to be a book in this, and that's what led to my book about him, which is kind of an intellectual biography, and it picks up on a kind of kernel of something that von Neumann touches on, and then it sort of follows that through to the present day. And that's how the book works. It's kind of thematically organized. It's not really a biography, although there is something of his life in it. And that I've found either really annoys people when they find out that's what it is, or they absolutely love it. So you should go away and read it and find out which camp you fall into, but only review it if you love it, please. So why am I here? So I am actually here for the current workshop that said in the title, it was about quantum complexity and how something from quantum gravity naturally arises out of quantum complexity. I've been here 3 days and I'm still waiting to find out what that is. But I'm told tomorrow is the day where I find out. But I have in the interim learned a lot about theoretical computer science, though mostly by talking to people during the intermission, because very few of the talks make any sense to me. It was great to, and Suskind was here as well on Monday, which was brilliant. So yeah, that's me.
I don't need this one because I have.
Oh yes.
Okay, hello everybody. I'm Ben. I have, as Sampath said, I used to be a physicist, and after 9 years of doing that, I decided to change my mind. I became a journalist. I wrote about the shortest path from physics research to theoretical computer science writing, as you might imagine, is through physics writing. So I did that for a little while. Then I got this job at Quanta, writing about computer science, which is a really fun topic, echoing a little bit of what Alex said. I have very little competition, so that's fun. You don't really have to worry so much about getting scooped. And I mean, the reason I went into science writing in the first place was to learn a lot of new things, and so it's learning even more new things. It's a tough area to write about. I think we'll probably get into the questions later, so I won't say more about that now. But I guess I'll say, what I'm doing here. I'm like Ananyo, I'm attending this workshop on quantum complexity theory, which intersects a lot of the subjects that we care about at Quanta. So no specific project in mind right now, but I'm just letting all of the PCP theorem, QMA, QCMA, all of these terrible acronyms that you guys have invented, I'm letting them wash over me. They'll filter through my brain. I'll catch some of them, talk to a bunch of you. Come and find me. I'm around the rest of this week and next week if you want to talk. Thanks.
Thank you, Ben. And as you can see, in spite of their surnames, this is no B list of science journalists. So let me see, I'm going to ask 4 or 5 questions and let any of you answer as you see fit. And then we will throw it open to the audience to ask questions as well. Okay, the first question is so that we can relate better to what you do. And I think I know the answer from your little descriptions already. What kind of background do you need in the area that you write about? And how deeply do you need to understand the work you're writing in order to write about it?
I mean, this is something I've thought about. I think, it's a double-edged sword to have a scientific background when writing about these things. I think it can help a lot just to have a baseline familiarity with a lot of the things you guys do in this world. There's extraordinarily abstract, and just the starting point is already, kind of a bunch of different things scaling as different functions of other things. And, having just that baseline familiarity and not needing to get on the same page about what various polylogarithmic blah, blah, blah means is definitely helpful, even though I don't have a specific background in what we're doing. I think it's also nice to not have a specific background in this subject, just because there's a lot of things one can take for granted. Basically, every story I write, there's something that just seems like, okay, everybody would think this means A in this context, but it means B. I was just talking to Bill Pfefferman earlier about how, in just random example that came up today, in quantum computing, the theory behind near-term quantum computing experiments was this thing called the random circuit sampling. And you might think, okay, random sampling, that's like a thing you do in statistics in general and probability. That's not what it means. The random is a different thing. So it's random circuit sampling. The sampling is also random, but that's not what that first word random means. And just like that, I just mentioned because I thought of that today, but almost everything is like that in every story. And so I think having a bit of remove from it is actually quite helpful because it gives you the ability to see what maybe other people take for granted because they've been talking about it for a long time.
I think that's right about the assumptions. I think it's good not being too smart. And actually, I interviewed Martin Gardner, probably the greatest of all kind of certainly mathematics writers. And he said, he found it all quite difficult. He struggled to understand a lot of it. But by struggling, you understand what other people are going to struggle with. Okay, so you might not, there are people who are reading it who are not going to be as smart as you, but you need to somehow understand what they're going to find challenging. So if you do an interview with someone and you go, oh yeah, I get it, you're going to find it quite difficult to explain that in a way that people are going to understand. So it's actually quite good to really think, to be forced to really think about it, because, and also to ask what is maybe a really dumb question. Because, first rule of journalism school, make no assumptions about the reader, like none at all. And if you come with this baggage of being super knowing everything about it, you're gonna just miss that. And I think that sort of, for me, the kind of first rule of science writing or good science writing is you want the reader to read it and feel cleverer, not more stupid. And it's quite easy to write something that people will read it and they'll think, I don't understand that. I must be really stupid. You want to give them something that they read and they think, oh, the clouds separate, and they get that insight, that kind of joy, that aha. So yeah, make people feel cleverer.
Yeah.
Sorry.
Did you want to respond as well? Or
I'll make it brief. Don't worry. Well, I'm glad that my failing first-year maths is apparently an excellent precursor to writing about maths for a living. I was actually told by a senior BBC journalist when I was starting out, or trying to start out as a science journalist, that having a PhD and having done research was a severe disadvantage. And I was also too old. I was 29. So, so that is the attitude that you will certainly encounter in journalism. I don't think it's altogether fair. I think it's certainly right that you can't be expert in all of the fields you'll be expected to cover if you're a generalist. So asking questions is the skill that you learn, and asking particularly stupid questions is and having no shame, I think, comes in very handy. So I think all of that is true. But I think the most useful thing about the PhD was understanding the way that research and science actually works. And I think that, if nothing else, if not the knowledge and so on, was extremely useful.
Good segue to talk about the kind of audiences you write for. Do you understand the demographics of this audience? Do you know how many male, female, how many people are young people just thinking about getting into science versus actual scientists? And do you know of cases where people have been, drawn into science by reading popular science books?
Okay, I've got the mic, so I'll go. I think as a journalist, you have to be able to write for different audiences. I think that's very important. I mean, I worked at Research Fortnight, which was aimed at kind of senior administrators and so on, and then Nature, which was the broader scientific community, and then The Economist, which was neoliberals. So you have to be able to write in different ways and get the hang of that quite quickly. What's the second part of that question?
Are people drawn into a career in science through the portal of popular science?
I was. I can't talk. I can't talk to everyone. I mean, I mean, almost every physics undergraduate of my age must have been baffled by A Brief History of Time. I think it was a bestseller. Amongst that, slightly less enthusiastically, I will say now, I read Surely You're Joking, Mr. Feynman. I was about to give it to my son, and then I started reading various bits of that, and I thought, no. I'm not doing that. Yeah, and various other books. That was certainly true. Yeah.
So I find that when I'm writing, I have this imaginary friend. Well, I know she's a friend of mine, but she's kind of my imaginary friend, and who knows nothing about the subject that I'm writing about. So in my first book, actually, before I wrote about computer science, about maths, I wrote a book on Brazilian football. It was a kind of through the lens of football about contemporary Brazil. She's not that interested in Brazil, and she's definitely not interested in football. And every sentence that I wrote, I needed to be able to imagine I was sitting next to her in a bar. I would have to say, imagine telling her that sentence, would she be interested? And if she wasn't interested, I'd have to write a better sentence. So, and also when I was writing my book on maths, same person, she's not interested in maths at all. I needed to make her interested in it. So I had a very clear idea that I was writing this book for someone who was not interested. And how do you make someone who's not interested in maths interested in maths? If you're going to say this is about maths, they're going to say I'm not interested. But if you say something like, here's a story about why we have 10 digits and not 12 digits. You phrase it in a way that encapsulates some idea and gets them excited, or you pose it as a puzzle, for example, which gets people going. So I always have this idea of trying to explain what I'm writing to someone who's not interested, and that's just how it works. And I would hope that you read my book on football not because you're interested in football or Brazilian football, but because you're interested in interesting stories and about the world. And you read my book on maths because actually it's not about learning maths, it's about great stories that happen to involve maths.
Okay. So zooming in a little bit into what we do here, does the public really understand what theory is as different from other parts of science or math? It seems like the stereotypical image that the public has of a scientist is someone in a lab coat doing crazy experiments, while at the same time, many of the most famous scientists seem to be theorists. So what is the public's view of a scientist? Where does theory fit?
Yeah, this is a tough question, but it's a very good question. I think, so we are living in this peculiar mixture of situations where theorists are very famous, but the practice of theory or like math, theoretical science is much more opaque than the practice of experimental science, where you can point to, yes, they built that thing, and then they looked over there. I think a thing that people don't really understand about theory is the degree to which it's often collaborative. Of course, this is a very widespread myth of lone genius just standing there in front of a board, and then they just write something down or whatever. They have a eureka moment. They're walking around outside, but just observing this workshop over the last couple of days, there's people chiming in the audience. That people are say things like, oh, roughly, morally speaking, this is the basic idea. It's kind of like, this is not quite right, but you can probably make this rigorous. It's a lot more intuitive, I think, than people realize. And yeah, so a lot of it is kind of hashed out in this informal way. And then kind of the details are hammered down later. I think that's a thing that doesn't come across. And it's hard to convey that in a story. Like, what is the process of doing theory? Well, they talked a lot of math back and forth at each other. So that is definitely a challenge.
I mean, I think that in maths, in computer science, you have theorems, and that's very different from theory. And I think that people, it's true, don't really understand the difference between just like a theory, which can be disproved, and a theorem which can't.
Right. Because at the assignments, we are often doing the math kind of theorem rather than theory, I guess.
Yeah. Exactly. So I think that one of the sort of the nice things about writing about this area is that they are things that can't be disproved, and they are kind of building blocks, and you can kind of build it. And it's not that someone's going to come around and push it all away and build a new one, which you get in other sciences. But also what that means is that if you're explaining something on the top building blocks, you've got to explain quite a lot of what comes before. So it then becomes quite difficult. So you've got to find tricks in order to do that.
Zooming in even further, I guess I want to talk about algorithms now. The word algorithm is indiscriminately and often pejoratively used these days. And there are legitimate concerns about, systemic discrimination, privacy loss, job loss, and other harms that algorithms can do. And you could replace algorithms with artificial intelligence or machine learning and make the same kinds of statements. How do you write about any of these things, algorithms, artificial intelligence, and machine learning, in a balanced way, acknowledging the public's fears, but also pointing out the possibilities of these technologies?
Gosh.
I think you should go first, Ben. This is your.
Okay. Yeah, maybe on the algorithm side, I think this is a kind of funny situation where the word algorithm is often mostly used for kind of the least most inscrutable algorithms, which is not actually how practitioners really think of this word as being used. Like Spotify and whatever YouTube are the algorithm. But I mean, a thing that it's almost a commonplace, but to remind people, in stories, well, what is an algorithm? It's a step-by-step procedure. That's the simplest, version of an algorithm. A recipe is an algorithm, and then you can start to vary that and say, well, now you can say, well, my algorithm, I don't actually want it to work always. I only want it to work some of the time, because having it work always would be too much of a too high a bar. Or maybe I want it to incorporate a bit of randomness, and all these different things, ways that I can vary that and ask what happens. I think there's to plug somebody else's work. I recently read this book by somebody who was a previous science communicator in residence here, Brian Christian and Tom Griffiths, called Algorithms to Live By. I would recommend this to anybody who wants to think about kind of how to talk about algorithms. It really gets at this kind of question of we can ask about a lot of problems, computational problems. We can ask, well, how do you think about this algorithmically? We can ask those same types of problems about situations that arise in daily life, and you can think, well, sometimes there are no good algorithms for that problem. Or depending on how exactly we pose the problem, the best algorithm might become the worst algorithm. So I think the positive side to this way of thinking, it really forces you to clarify what kinds of questions you're really talking about when you're trying to solve problems. And that, I think, can dispel a little bit of the mystique around
this. So in The Man from the Future, I had to deal with, I guess, a period of history where, the process of algorithms, the concept of algorithms was sort of being invented. And it came about because of the foundational crisis, at least that's, my impression, which forced mathematicians to think very hard about what could and couldn't be proven through step-by-step processes. And, I found that a fairly kind of clarifying process of saying, this is what it's about. It's like, so in a way, if you're communicating about algorithms, it should be the most straightforward part in some ways. I mean, it isn't, but in a way, it kind of should be. You break stuff down into simple steps, and you tell people about them. I think what gets in the way is mathematics. People are very nervous about mathematics, and publishers in particular and editors are very nervous about mathematics. So I felt if I was going to write a book about a mathematician, I had to kind of bite the bullet and at least give people an idea of what he was doing and how he was thinking. And, that was that was a risk. But I think my publisher at least thinks that risk paid off. And I've noticed that there is something of a small trend with people like Sean Carroll and so on embarking on books that are popular science books, but he's trying to kind of bring in the maths, the kind of minimal level of maths that you might need to get a real understanding of those fields. So I think they're it's kind of wrapped up with the question of communicating theory and algorithms.
I just think it's quite good that the word algorithm is now, it's a normal word. Everyone understands it. 10 years ago, no one did. So actually, this is part of theoretical computer science slowly kind of seeping out into the sort of public consciousness. So one of the difficulties of writing about this area is it's so full of jargon, or technical terms that have specific meanings that it's kind of the public don't really understand or have slightly different thoughts. But the word algorithm is now something that you can quite happily use in a story and kind of assume actually that people are more or less going to understand it. So it's actually quite helpful in terms of explaining what's going on.
I have a few more questions, but let's turn it over to the audience because I'm sure there's a lot of questions there, and maybe someone will pass the microphone around. And anyone have questions? Right here.
Hi, I'm Christoph Drosser. I used to be a journalist in residence here, and I'm a colleague. So, and one question, so I write about math and computer science, not exclusively, but one question that I'm always struggling with is in other sciences like biochemistry, if you read about it in the press, it's always the cutting edge science. What are they doing in genetic engineering, blah, blah, blah. The math stuff we're writing, and have written books like you, Alex, is a lot of, the math is old, right? It's just you find a new way to relate it. But can we report on the cutting edge science in mathematics or theoretical computer science to a general audience? And what elements do these stories have to have that we can relate it, right? Does it have to be relevant for the reader? Does it have to have protagonists that are interesting from their biography, or what is it? And I think we don't find these topics often. Whenever I went to a talk here and turned it into a story that I'm beating the hell out of now because it's a great story and it's cutting edge, but it's very rare to find that we even can relate the stuff that people are talking about to a general audience. And I would like to get your take on that.
I can start with this one because this is basically my job. I guess maybe for those of you who aren't familiar with Quanta magazine, I'm doing sort of journalistic writing about new developments. I've never written a book. Thank you. So I do the computer science side. I can't speak to math, though. I will recommend our math writing is also pretty good. I think you do need to have, I will sneak in an answer to one of your earlier questions here. So Quanta, I think a lot of scientists read Quanta. I read Quanta when I was a scientist. We have a reputation for being, a lot of, for scientists. This is not actually true. 80% of our readers are not scientists. And I think the reason that we reach these people is that we do care a lot about storytelling. And storytelling can mean a lot of different things, but it's somehow kind of, I think Alex put this very nicely earlier, not assuming your reader comes in with an idea just like, oh, obviously, the P versus NP problem is interesting. I already know what that is and I already care about it. A story might, the protagonist of a story, the reason to care about a story might be to greater or lesser degrees depending on the story and, how much I, as a journalist, can kind of coax people to come out of their shells. It might be the people who are doing it. Sometimes there's a great origin story for a particular piece of research. It might be the historical context leading up to the work. But in any event, like research, the practice of research is done by humans. It is a process that unfolds in time. People get excited about different parts of it. And then we strip away all those narrative elements. Well, I'm not me anymore, but it used to be me. When we write papers, yeah, sure, we say, well, this is the historical context, and this person did this, and then this person did this, but basically all of the drama gets lost. And I think to turn that into a story that most people want, you're not like making things up. You're kind of trying to put back some of the, here is why people did this, and this idea led to this other idea, and that inspired so and so. Yeah.
Okay, that's a question back there. Or did you want to answer this one again? Or there's another question. I guess we might as well do lots of questions. There's one question on behind you.
Where? Oh, okay.
Well, we've said that there isn't a lot of popular writing about algorithms, but I'm going to ask about a field where there is a lot of popular writing. And the question is, how do you deal with science writers who try to write about entanglement and get it wrong? Like, they are always talking about spooky action at a distance. And Einstein was one of the most harmful things he did. I would say that this idea refuses to die, and that's sort of spukhafte Spätwirkung, spooky delayed action. And it's a simple idea, but it's so counterintuitive that many science journalists don't understand it. I guess this is a problem. If you are in this field, how do you approach your colleagues who are muddying the waters?
I'm not sure how to answer that because I never write about physics, and quantum is baffling to me. So you're the guys who've been here this week. I mean, maybe.
Well, I had to actually give explaining entanglement a go, and you pretty quickly, after delving into it, you discover it's neither very spooky nor is it action. I think it is at a distance, but yeah. Yeah. So there you go. At least one person has got it right. Huh? You should buy my book. I did want to say, I don't think it's true that people aren't writing books about algorithms. I think they are. Cathy O'Neill's Weapons of Mass Destruction, for example, I did very well. And that was all about the bad assumptions that are rolled up into them. So I think that was extremely valuable. And I've just read a book ahead of publication called Playing with Reality, How Games Have Shaped Our World by Kelly Clancy. And that's about game theory and the algorithms behind auctions and all sorts of stuff, and the assumptions that are embedded in there. And her argument is that unless we understand those algorithms and the assumptions, then we're playing along with a game that the only way to win is kind of to break out, to not obey the rules. So I think it's becoming more and more important. I think more and more people are writing about it. Sorry? The new one, that's called Playing with Reality by Kelly Clancy, and that's coming out, I think, in a couple of months. I said something nice about it. What do we do about people who can't communicate entanglement? I think we should send them to prison.
I guess a little bit of a follow-up to that. I mean, I guess when you're talking about scientific debates that have policy implications, for example, the question of climate change, then, I mean, this is not really theory as we do it here, but still, what do we do with journalists who may spread, false narratives on this? What are the ethical obligations? What are the best ways to communicate the truth here, as we know it?
Another really, you're really giving us the easy questions.
No, but
yeah,
you might know better than me. So.
Well, I mean, I have the luxury of not having to write about, everything I write about is in like the asymptotic limit of, theory, very, very far from reality. Not reality, sorry. Very far from practical application these days. Usually. Now, I do think that kind of, in general, I think science journalism could be better served by kind of getting more into the how of any story, and kind of this is sort of related to what I was saying, but again, it's a science unfolds as a narrative. Like somebody did this for this reason, and then this happened, and like somebody had this idea, it didn't work, so they tried this idea. I think often, for very good reasons, not misinformation. These are huge problems, but people sometimes try to speak from a place of argument from authority. They're just like, I listen to the experts, so now you listen to me. This is what's up, and that is not a good way to get people to trust you. Now, I have, like I said, I'm easy mode because I don't have to, write about global warming. But I think people can tell when you're just telling them shut up and listen. And the point of science is it's not shut up and listen. People believe it for a reason, and getting into kind of like the how, I think, does help.
One thing to say, I don't think the problem is as that bad. 30 years ago, when I was starting out in newspapers, I was the only person with a science background. No one else who had in the newsrooms. I worked in many newsrooms, so much so that one of the first jobs that I had was for a local paper, and there was lots of traffic congestion. So the editor said, "I've got a really great idea for a kind of prize draw. Because guess how many traffic cones are on this main road that goes through the city?" And he thought, no one's going to get the right answer. Actually, all you need to do is like measure the length of the road and the distance that the police put cones, and you get the exact right answer. And sure enough, someone sent in the exact right answer. And then the guy was like, I can't believe it. The first answer is correct. So it just showed the huge innumeracy in newspapers. Now, there are lots of people with science backgrounds in newspapers. There are special courses that you can send, like for statistical training, that you can send people on. There's data science. It's like a huge bit of newspapers where people who are kind of trained in understanding numbers and data. And I think, even though it's slightly off topic, in the whole COVID thing, you saw there was a lot of great journalism by just general reporters who could have, or explaining exponential growth, all that kind of stuff. So I think that actually it's all education, and it's having numerate people who are writing the stories. And then, the science communicators, we're fine. It's the ones who are, the politics reporters, the general reporters, and their level of numeracy is so much better than what it used to be.
Yeah, so I agree with that, and I would say, I don't know if this is a controversial statement here, that science journalism is rather good, and I'll say that because nowadays most science journalists, and I think this has been true for a long time, especially the specialist correspondents. If you're a political journalist, it's completely fine to quote a politician, even if you know that what they've said is essentially false, right? Somebody said it, you can quote it, right? That's the general standard. A science journalist would never do that, at least not one at all worthy of of being called a science journalist. If you know that a scientist is basically trying to overhype their story, or they're embarking on some criticism often of a piece of research because you know that they're biased. Most science journalists I know, and admittedly I've not worked for tabloids and so on, will kind of go, are you sure? Are you sure? And or they'll either drop the quote and find somebody else who's less rational. So I think in many ways, science journalism, the science is really very well served by journalists. And of course, if it's a political issue, like climate change, that may well get terrible reporting. But I don't think that's because these people have misunderstood the science. I think it's because there's a vested interest in misrepresenting science, and their beliefs and so on will get in the way.
Hi,
Thank you for all of your insightful answers so far. I think this is sort of actually related to the last few questions. But I was interested in your sort of, I guess, attitudes and also in practice, how you balance your approach towards, I guess, like narrative archetypes and connotations that come up in science. So we've already talked about like entanglement. There's some like public perception of what it is. And you sort of have to balance that in your writing and figure out how much you want to disturb that. Or like algorithm is now a word that's well known and well used, but then, you know, like how much of that comes with the connotation and baggage of like TikTok and YouTube and like, as opposed to like an actual scientific context. So, you know, I guess just your thoughts on balancing that and either like using preconceived connotations or like creating new ones in your work.
Yeah, another tough question. Yeah, I think there is definitely a danger in using, like when I start to write a story, I make a long list of everything that might be considered a piece of jargon by anybody, and then I just like slowly sift it into a list of the things that are going to go into a story and aren't going to go into the story. And yeah, what's especially dangerous is jargon that people think they know what it means and they don't. I mean, the thing that comes up for me a lot is in any story involving a quantum computer, I have to say something like, you know, okay, so you have all these different parts of the superposition, like, but wait, you know, you can't just do everything in parallel because this is like, so you kind of have to pick your battles, obviously, on which boxes you unpack, and sometimes that's going to be, often that's dictated by the needs of the story, because if there's something that, you know, I find if somebody doesn't understand this now, the whole story is gonna get lost. Then you really need to kind of spell that out. But in general, like, you know, as much as I would love to kind of explain everything in a story, like I've learned from experience also that, you know, suppose I say 10 things that I think it would be really cool if everybody understood these 10 things, and, you know, somebody will come away and read it and say, hey, this is awesome. I learned the first thing, the fourth thing, and the ninth thing, and the, you know, like I shouldn't have put the ninth thing in there because they like that was not the most important thing to take away from this. So even when there is an opportunity to kind of clear the air on something, sometimes just kind of overloading people with information can itself just be counterproductive. So it's very tricky.
Yeah, I mean, when you're writing, it's a process of simplification. And you've got to somehow keep that balance of not simplifying too much, but simplifying enough that the person will understand. And often you have to play into people's prejudices. So if you were going to say, use the word algorithm, you might have to, you know, say, oh, like in Spotify and TikTok, but no. So you kind of, there are different ways of doing it. And there are many ways to answer that question because it depends the type of article that you're writing. If you're writing something that's a bit more serious, say for Quanta, or if you're writing something for a tabloid, or if you're writing something which is at book length, it really depends. But there are lots of just journalistic styles of writing. Quite often you could say something, say, okay, that's an oversimplification. I'll come to it later. There are lots of ways, signposting is one of the most important things to learn. I think when you're being a science journalist, you want to kind of say, I'm going to say this and then say it in a way that you don't lose the people that don't quite understand it, but you don't bore the people who already get it. So you need to use that with kind of tricks. And one of the ways that, I mean, Quanta definitely does that, and I definitely do it, is that if you've got some really interesting advance that you want to write about, is get a quote of someone, just say, this is an amazingly interesting advance. I mean, it's just, you're padding it out. It gives time for the person who's trying to understand what the advance is, but the person who understands it kind of quite likes to feel that it's kind of exciting. So there are lots of ways that you can sort of get that. And the hard thing about writing about an area which is conceptually difficult is level. You want to not lose the people who find it hard or the people who find it too easy. So it's the problem that you get in math class writ large, which is, where do you aim this class? We want to not bore the people who get it easily, but we want to not lose the people below. And so you've got to depending on your medium, your platform, use certain tricks.
Yeah, so I will say it is audience dependent, and I will add that unlike Alex's editor, the editor of the science and technology section of The Economist, if I ever dared put a quote in that was celebratory like that, send the story back, that quote's out. In fact, Jeff would methodically remove any color or quotes from my pieces. So I had to learn very quick. If you read The Economist at all, if you read the science section, it's very much like the voice of God coming down. We are here to tell you what has happened, and you shall know. Oh yes. So yeah, that's so. And in terms of jargon, I think it is a mistake that people make early on in their careers, and it's usually a sign that you haven't understood the story well enough to be able to communicate it at the level that you need to be able to communicate it. Now, the other thing I've noticed, and science journalists even older than me have noticed all the more, is that what we used to regard as jargon is no longer jargon. We don't have to explain gene anymore. We don't even have to explain what DNA is. Everybody has an idea of what that is. And I think algorithms probably going the same way. So yeah.
Well, I think I'm going to ask for more coverage and less depth because there's a lot of questions from the audience. So we should try to hit as many of them as we can.
So I'm going to ask a question about mathematics education. We talked a lot about communication. But if you go back all the way to elementary school or middle school, are we teaching mathematics incorrectly to kids? I mean, or is math education in the US different from maths education in the UK? For example, there is this author, Ben Orlin, who wrote this book, Math with Bad Drawings. He gives this example. Many elementary school kids, when you ask them, what is to fill in the blank, 3 plus 6 equals blank plus 2. The answer is 9, according to a lot of the kids. So are we thinking about teaching math wrong elementary, middle school level?
I'll be brief because this is a massive, massive subject. You can talk to hours and hours. I don't know enough about the US, but in the UK, huge amounts of thought is given to teaching maths at elementary school level. And the big change there has been, I mean, there have been lots of little changes, but the big change there has been is that previously people thought you need to get abstract really quickly. And now people think that's bad. That just confuses people and you lose people. So stay with kind of physical things. So learn like objects, kind of try and link the fact that there's kind of concrete things that you want to do the counting to get numbers, and leave all the kind of, there was a time in the 1960s where every elementary school kid was taught set theory. And that was actually a result of Sputnik and people thinking, oh my God, the Russians are really clever. We need to introduce advanced set theory. It's called the new math. I mean, I think Tom Lehrer was writing about it, and that's an absolute disaster. It's far too complicated, just lost everyone. And now it's gone the other way. So I know, bring back the abacus.
So my eldest has been through primary school and in Britain, and yeah, I think it's brilliant. I think the new way of teaching maths is absolutely brilliant. It's Singapore maths, as it's known. It's actually based on American and British research, but Singapore was there first in instituting it. And what I really like about it is that for every concept, even if it's addition, they will show you 4 or 5 different ways of approaching the same problem. So what it's teaching is proper maths, which isn't just applying one method to one problem and getting it done, but having a sort of toolbox and understanding how to approach a problem. I think that's so much better. Sadly, secondary school maths has not gone through a similar revolution, so I wish it would.
Dan.
How do you see the survival of serious computer science writing in the age of AI journalism? It's like AI is everywhere. Even work troublesome to me than the problems of communicative entanglement.
Oh boy. Yeah. So I think I think yeah, it's a really big problem that the sort of industry is I think going to be convulsed by this. I don't think all human, like I'm not, I guess, personally worried that my job will be automated away, maybe because I trust the good people at Quanta magazine, but I think there will be a kind of positive backlash to this to some extent, though it's still a kind of a grim prospect. But you know, people as the disadvantages of current generation of AI mass produced prose become ever more apparent, people will realize, oh, there's actually something good about human writing, even as it gets better. I think, I mean, you see something similar with like physical goods that can be mass produced, and people place a premium on like certain artisanal handmade things. Now, I don't know if this like bimodal world where most things are produced by AI and a few things produced by people are actually good, but I do think there will be a persistent demand for things that people put out with a lot of intention.
So I met a string theorist from Google yesterday, and so we went to the pub, and he said, "Yep, AGI, artificial generated, it's coming within 10 years. All but the top 10% of science writers are going to be out of a job." And then he paused and says, "Oh no, I think you'll be okay." Thank you.
Lenore.
Actually, I think Dan's question was slightly different. I think he was asking that AI is overshadowing mathematics and computer science.
Okay, sorry.
Yes.
Actually, I have a different question. This question. Did you hear me? Because it was off.
Yeah, sorry, misunderstood the question. Guess we're thinking about our own jobs here as well. Yeah, I mean, at Quanta, of course, we do try to cover a lot of these areas. I mean, machine learning is also something we cover. We try to cover it more on the theoretical side. So trying to figure out what's going on inside these models, that's easier said than done. Yeah, I guess I don't have a good answer to that other than we will keep doing it, I promise.
Yeah, so my question was a little bit more like what you answered. And I wanted to know what you think of the future of science journalism two ways. One is journalism itself is, tanking because of social media. So that's going to affect science journalism. And the second part of my question has to do, at least with US population, which is very anti-science these days. And so where does science journalism fit into a world that's really anti-science?
Yeah, I guess these are also hard questions. I maybe haven't, a little bit get off the hook for this one because my audience generally is already somewhat bought into, I think in some sense, Alex was talking about this very noble goal of trying to write for someone who simply does not care about the subject. And I also, try to imagine that my readers could just leave at any minute because they're like, this is getting boring, or, now I don't understand. But I think generally people, our audience at Quanta is kind of a little bit bought in already. Yeah. So I don't know, maybe.
I think in terms of books, the future is quite good for popular science. Just if you take a slight kind of long view, 20, 30 years ago, there were very few popular science books coming out. And now there are huge tables when you go into bookstores. And in the UK, they've renamed it. They call it smart thinking now. So there's a huge amount of different areas. Every week there's another book on astronomy, books on DNA. I mean, and hopefully in a few years' time, there's going to be more stuff on theoretical computer science. But I think the world is changing. People, there are a lot of people who, don't believe in evolution, but there are also a lot of people who do believe in evolution and who want to know how the world is working, who are fascinated by learning stuff out. And I think long form, one of the things which the internet has introduced is this idea of the long read. it's kind of like halfway between an article and a book. And that never happened before. And probably all the big ideas, the big great bits of journalism that I've read recently are these kind of long reads. So actually, I think it is a kind of golden age for science journalism, because people are interested and there's lots of interesting stuff happening, and there's now lots of platforms for it. I kind of think, even though there are depressing things that if you are a freelance science writer, you can't pay the rent.
So let's try to squeeze in at least a couple more questions. Sorry, I'll have to hold you off for this one, because you can answer the next one first.
When dealing with these very complicated esoteric concepts, is there anything that you've written for a lay audience where you're like, this is the best metaphor, it's succinct, it clearly explains a complicated thing to a regular person, you're like, I'm going to keep that metaphor in my back pocket? I'd like if each of you, rapid fire, could tell me your favorite metaphor.
I hate metaphors. I didn't.
Or
use any in my
simile,
book.
which is a kind of metaphor.
Pass.
Oh boy. Well, since it's rapid fire, I'm not sure I have my favorite one yet, but I will say I like Rubik's Cube as a combinatorial object that, it's an NP problem. You can, imagine trying to get from some starting point to some finish point. For those in the audience who knows what this means, it is actually a great example of why greedy algorithms don't always work well. If you are like, well, I'm going to try to get to the end as fast as possible, and I will do that by just trying to make this face all one color, and then I'll be close to making the rest of it. That's a bad strategy, and that isn't that's a great illustration of a thing that's often the case in algorithms.
Great analogy or great metaphor. It's not mine. It's Scott Aronson's, and the difference between things that you can do in polynomial time or exponential time, he says there's a kind of invisible electric fence between them. And I thought that was just really nice, because when you're in the area, that's one of the first things that you learn. But to explain something outside the area, that actually you can divide all these things that computers do kind of into, they do go into two sides, but what's in the middle, just something kind of invisible but strong. I think that's really, really nice. So that's a great analogy, and I love them. Sorry. Maybe it doesn't exist. Someone could switch it off. Yeah.
Maybe we're perched on
Thanks for everything you've been saying. It's been really interesting discussion. I want to ask if there's any topic that you really wanted to write about. It was a very exciting development, but you couldn't find a way to communicate it.
I have lots of things that are on my maybe I will figure out a way into this list, but yeah, I guess.
That's the sort of exciting bit of the job, that you think, here's this complicated idea. So one idea that I'm trying to put in my book is a differential privacy. Kind of quite complicated, quite theoretical, but also really interesting. At the moment, I haven't worked out how to do it, but I'm going to get there, and there's going to be a chapter on it, because that's what you try and do. And that's kind of, I'm not going to invent a new theorem, but I'm hopefully going to maybe find exciting ways to bring some of this theory so that someone like my friend who is not interested in anything is going to be interested in it.
Yeah, I think this is a problem, but this is kind of the, I see it as a sort of journalist job, which is to take something that is way too nerdy for the normal journalists would just run miles from. I want to write about Calabi-Yau manifolds, but nobody's going to let me. So I have to find a way to write something which is in fact about Calabi-Yau manifolds, but it is about how physicists have databases full of universes, and maybe one of them is ours, or something like that, right? Mm-hmm. So you try and find some weird thing.
Right. So one more question from the audience, and then
okay,
I have one.
I'd like to ask you how you write about experimental science versus theoretical science, because so last year there was this superconducting as room temperature superconductivity result that never was reproduced, as far as I know. And it sort of hits a little different than math papers, which sometimes have errors. And, there's a reproducibility versus verifiability sort of delineation there that I find kind of hard to explain myself talking to other people. So how do you go about explaining that these two areas maybe differently?
When writing about math, it's quite rare that someone will find an error in some old math paper. So that doesn't really appear that much. I don't know about writing about physics.
Yeah, I mean, I guess these days AI is a little bit like this, the machine learning coverage, that it's not that, you know, I mean, there's just reproducibility issues in general. It's like you got your language model to do this, but like, you know, maybe it was in the training data set, or you got your language model to fail at this. Well, maybe you just didn't do it right. So there's a lot of papers that kind of contradict each other in some sense. It's very hard to cover this kind of field, but I think it's, I mean, the best thing you can do in that case is sort of just try to really explicitly lay out, here are the possible ways this could not apply to, you know, generalized to other situations. That's not a very good answer, but I'll think about it.
So I think we're almost out of time, so let me ask one last question. It's a little bit self-serving. Theoretical computer scientists are always facing a funding crisis. They don't have enough money to do their research. And one way they could succeed is to better communicate their research to the public, and thereby to the politicians, and thereby to the funding agencies, and thereby get lots of money. So what advice do you have for us about strategies for communicating our work?
Rebrand. So I think one of the major problems with theoretical computer science is the name, theoretical computer science. It just sounds, it's a bit meh. You know what I mean? That's why AI sounds exciting.
So what would you suggest?
I don't know. I mean, the value of a good name. And I think, or something like that. I mean, I can remember 2 years ago when I discovered theoretical computer science, people would ask me and say, what are you working on? I'd say, something to do with theoretical computer science. And they were just like, oh. It scared them. They didn't understand what it meant. So I realized that I had to start saying something else. You know, I'm, you know, this area which underpins everything that you're doing now on your phone or something like that. You just phrase it in a different way. So I think that one, I mean, it sounds a bit flippant, but I think that often there are these buzzwords that if you want to catch people's attention, you've got to brand yourself in a way to get that attention.
If you think the theoretical computer science is bad, then, you know, wait till you hear about what people in theoretical computer science name the specific things they work on. An absolute nightmare. So, you know, I'm in this talk about the difference between QMA and QCMA with this kind of oracle or this other kind of oracle, a classically accessible quantum oracle versus a quantum oracle versus a classically accessible classical oracle. You know, okay. Yeah. So, but the cat's out of the bag there.
With differential privacy.
Yeah, differential privacy is great. Yeah. You know, that ship has sailed certainly, but I think, you know, turning, you know, just really getting at kind of like, again, it's a question of what's this, like, why do we care? What is that might be like because of an impact on the real world. It might be because it tells us something like fundamentally what is, you know, the difference between quantum and classical in this domain, like rephrasing these questions as into like, what motivates you to do it? It certainly wasn't the acronym. Like, so, you know, get that out first and you'll be all right.
Okay, I think we are just out of time. Thanks to the audience for some great questions, and thanks to the panelists for a lively discussion. Thank you.